All right, this is a difficult one. It's going to take a bit. So we're drawing a Lewis structure of SOF4, which means we got an S with 5 bonds on it. So we got a, not an exception to the kind of 4 bonds rule that we're going to look at. And then we're going to look at, is it polar or non-polar? So let's start, and notice it says minimized formal charges. So that's a key. So let's use that formal charge button and also understand what does it mean. So I'm going to go 5 bonds and start adding. My fluorines. Now we know fluorines like single bonds, and they bring 7 valence, so we're going to give them their 6. Now you should still be doing the Lewis structure format where is the right amount of valence electrons for that pot that we have to work with. And so fluorines each bring 7, sulfur and oxygen each bring 6. So let's look at our formal charges so far. S is a +1, right? So we could go like this. Now, do we have the right amount of electrons? I think so, because we're adding up a formal charge of 0. So let's see, let's calculate this out. We got 4 fluorines, bring 7, there's 4 of them. That's 28. Sulfur, there's 1. So what, 34, 40. So we got 4 groups of 8, which is 32, plus 2, 4, 6, 8, so 40. So we're at 40. But we see that we still have a +1 and a -1. Can we get rid of that? Well, we know oxygens will always have a -1 with a single bond and a 0 with a double bond. I've seen that a lot. So let's try reducing that to 4 and giving it a double bond. Let's see what it does to the sulfur. And that also has a 0. Now remember, formal charge, sulfur brings 6. It's got no lone pairs now, and so now it's got 1, 2, 3, 4, 5, 6 bonds. So that's 0. That's how we calculate formal charge. Oxygen likes double bonds, fluorine likes single bonds. And so that is so we got 6 bonds on the sulfur. So that's kind of, right? It's not typical, but that does use the right amount of valence electrons and has reduced formal charges to 0s. So let's put that in. Now let's think about, is this polar or non-polar, right? And so fluorines will always have, and since they're not all canceled out, they would be canceled out if this oxygen was a fluorine as well. We have this dipole kind of going probably in that direction somewhere. And so that would be, and fluorine's stronger than oxygen. So we're gonna have a polar molecule. So that's a tough one. Utilize those formal charge buttons, make sure you're counting up electrons when you do it and that you're using the right amount of electrons.